What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series, we are going to be going over cleaning up our project so that we can get ready for more advanced mechanics such as online multiplayer, rollback, AI, story mode, and a lot more. In the previous episode, we went over cleaning up our hitboxes part 1. And we're going to continue doing this because there's a few other things that I want to clean up so that I can get to cleaning up my animation blueprint further. And when I do that, I can clean up my game mode blueprint further. And then we'll be pretty darn close, if not, at that point we'll be pretty darn close, if not fully ready to begin doing a deep dive into AI and more multiplayer mechanics. So specifically for today's episode, I just want to clean up some more of the functions. If you guys watch the camera episodes, we basically converted everything from blueprints to code, or the vast majority of blueprint logic to code. And we're going to be doing the same thing here because a lot of our hitbox logic is very simple. It is not something that needs to be in blueprint, and it will be faster if we take it out of blueprint. So we might as well convert everything now that we have our logic in place, and that's what we'll be doing for today's episode. If you want to get caught up in the entire series and check out how we've done things like throws, projectiles, commands, and a lot more, feel free to click the link in the top right corner right here, which is the entire playlist to the fighting game tutorial series. If you're just interested in cleaning up hitboxes and keeping a hitbox class for your game that is clean and organized, I still recommend you watch the initial hitbox episodes because they are relevant, they are useful. We're not changing the behavior in these episodes, we're just improving the logic, cleaning it up, making it more efficient, that sort of thing. I'll link you to the first hitbox episode right here in the top right corner. With that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series, and since we are converting logic, we're going to be converting blueprint logic to code today, so we are going to be in both. Let's go to our hitbox actor blueprint, which for me is in content, blueprints, functional BPs, hitbox actor BP. And in the previous episode, we converted the actor component of the mesh to a C++ component and remove the default scene root, which made this cleaner and easier to use, and then we can also edit and access this in the code. I want to clean up our functions here because we have a lot of functions and many of them are very simple and don't rely on anything blueprint already. So they are very simple conversions and they will get us a performance increase. The two main ones I want to focus on today are determine full damage and determine true hit stun. So these functions were implemented to change the properties of the hitbox if we're in certain modes. So for example, if we have what we call installs or power-ups for our character, and they can use their same hitboxes, their same attacks, but when they're in this mode, maybe those attacks do more damage or have more hit stun. These two functions will take care of that. Additionally, we have this hitbox owner variable that I do want to make a code variable. This is very, very useful, and we should have this as a code variable in my opinion, because then we can determine who the owner of this hitbox is from code, which previously we could only do in the blueprint. And this is going to be useful pretty much everywhere in our hitbox. So let's hop right into it without wasting any time. We have our hitbox owner, let's start with that. So if we go into our code and specifically we go to our hitboxactor.h. If you don't have it open, of course, just go to your folder here and you can find your hitbox actor class. Now I'm going to scroll down past my structure for my hitbox to my actual class, and I'm going to go down to my variables and I'll put it here. So we want to call this the owner of the hitbox. And in the blueprint, this is a fighter template character object reference. So we might as well make this a pointer in here to make this much cleaner. So a fighter template character pointer, hitbox owner. And if we don't have the type in here, that's fine. That's just because we haven't included it in here. So we can go up to our includes, and we have to go above our generated.h include. If not, we won't be able to compile. And we want to go hashtag include and fighter template character.h. Now we have our include, so when we scroll down here, this type will be found. And we want to make it a U property so that we can edit it and access it in the blueprint, because we absolutely are going to need to do that. So U property, edit anywhere, blueprint, read, write. So we can edit it in the defaults in the graph. We can see it in the defaults in the graph. And I'll just give it a category of hitbox to stay consistent here. And now we have our variable, and to set this properly, if we go to hitboxactor.cpp, we can set it in here. So we can say hitbox owner equals null pointer. Now, one thing I did show you in some of my other episodes was an initializer list, which is a little bit faster initializing things in the constructor body, and I went over why in those other episodes, specifically the character cleanup episodes. We haven't done that yet in this class, and I'm not going to do it in today's episode. We will be doing it in this hitbox cleanup. Feel free to get a head start and do that now if wanted. But either way, just make sure you set hitbox owner to null pointer. And now we have our variable. We technically don't have to do anything with this variable yet. The blueprint will still be handling it. We'll just make sure that we replace the blueprint variable with this one everywhere that we have it so we don't cause issues for ourselves. But the blueprint logic will still handle this behavior correctly. Now let's go to hitboxActor.h again, and we want to make functions for those two that I told you we were going to convert. So we can make them blueprint callable. That's perfectly fine. And we're going to want one for calculate the final damage of the hitbox based on buffs, debuffs, etc. And we'll make this U function blueprint callable, so we can call it from the blueprint because it is being called from the blueprint, and that's fine. We're just going to do the logic in the code. The return type actually isn't void, it is returning the damage, which is a float right now. So we can do float, calculate final damage. And then I'm going to basically do the same thing for the hit stun. So calculate the final hit stun of the hitbox based on buffs, debuffs, etc. And U function, blueprint, callable. And let's call this calculate final stun. I'm going to change the comment here, calculate the final stun. Because if we want to use this for hit stun or block stun, we should be able to do that. Even though I believe I was only doing it for hit stun at that point, but I do feel that we should be able to support both if we want to. It's a very simple thing to support. So calculate final stun. Then I go into hitboxActor.cpp and go to where I want to add these functions, which is going to be above my tick. And I'm going to go back to the header file because I realized that I made the stun one a float, but the stun frames are in just that frames, so it should be an integer. So damage is float, stun is integer. And we want to make these variables, so float a hitbox actor, : calculate final damage, and int a hitbox actor, : calculate final stun. And we do need to know the stun and the damage coming in. So we could actually just grab it from our hitbox. We don't have to pass it in those functions in the blueprint. I do pass them in. So if we look at these functions, they're called in the check collision function. So right before we are dealing the damage, we are passing in the damage from the hitbox damage or hitbox stun of the hitbox data structure that we have. We don't need to pass anything in here if we don't want to. If you want to, of course you can, but for us, we do have a hitbox data structure that has all this data. This is really all this is. This is hitbox data that is split so that we can see all the fields. If we come in here, we can just do hitbox data dot damage or hitbox damage to get our value there instead of passing it in. And for this one, it's going to be hitbox data dot hit stun frames. Now, this isn't our actual logic. We have to copy the logic from the functions, but that's how we can get what's being passed into each of these. If we go to determine full damage, start with the damage one first, we get the hitbox owner, and then we grab the damage install modifier and see if their install is active. And if it is, we use the damage coming into the function multiplied by the damage install modifier. Otherwise, we just use the hitbox damage and return it. So it's a pretty simple function here. We go into our code, we can essentially just check if hitbox owner to make sure that it's valid before using it, because if we don't have an owner of the hitbox, that's fine. Perfectly is valid to not have an owner. If you have a hitbox that you just want to spawn somewhere in the world and it doesn't come from a character, but then we don't want to do any logic in here regarding it because it relies on hitbox owner, then we just want to check if hitbox owner is install active. And I can't see this type. If we go to our fighter template character, we can search for it. And it is here, but what space is it under? It is protected. And so since Hitbox does not derive from the character class, we won't be able to see this, so we need a getter for it. So if we come down here to the very bottom with our public functions, we can add a getter for this. So it's a boolean. I'm going to say get the characters install active value. And we can say bool get is install active. And we can make it a const because the values in here aren't going to change. We talked about that a little bit in the episode for the character cleanup. And we're going to return is install active. So basically this is a public function or a getter or an accessor that we can call from another class without exposing that variable to this class. So now we can call if hitbox owner arrow is install or get is install active. And if it is, then we can use hitbox owner install damage modifier, which you'll notice we don't have access to this either. So we go to our fighter template character.h again, and we can go, let's keep everything pretty consistent here. Get the characters install modifier, let's say install damage modifier value, and we're going to return a float for that, and it's get install damage modifier const return install damage, or it's actually damage install modifier is the variable name in the code, and we can see that here. I like install damage modifier more, I think, so I'm going to call the getter this. Maybe we will rename the variable, but at this point we now should have access to that value, so we want to use hitbox owner get install damage modifier. Okay, and now we have the value here. So we already have this value, this damage amount, and we check if the hitbox owner is valid, and then we're checking if install is active. If it is active, we want to use this value and multiply it by our hitbox damage. So we can make a float above here. Let's say float final damage, and we can set it to hitbox data dot hitbox damage. So by default, the final damage is the current damage of the hitbox in case we don't modify it in here. But if the hitbox owner exists and if the install is active, then we're going to take our final damage and multiply equal or times equal it by the install damage modifier. Then at the end of this logic, we are going to return final damage. So if it wasn't modified, great, we return the same value. If it was modified, then we return the modified value. And we want to do the same thing for our final stun as well. So we're going to go to our fighter template character, and we're going to need a getter below here for our integer as well. So I'll put it here, and we're going to say get the characters install stun modifier value. Int get install stun modifier const, and we're going to return stun install modifier, and it is called hit stun install modifier. Again, we may want to do block stun as well. It is up to you, so feel free to call this hit stun modifier instead of just stun modifier. But now when you go back into the logic here, you see determine full damage is fully converted. So we want to go to determine true hit stun, and really it's the same thing. The only thing that's a little bit different here is we have a hit stun modifier, which is a float, and we end up truncating any rounding so that it can be a whole number of frames. So you technically do have to account for this. If you don't, it will do it automatically. Back in the code now, we have calculate final stun, and we want to do a similar thing. We're going to say int final stun frames equals, we can use this line we have here, hitbox data dot hit stun frames, and we need to check if hitbox owner is valid, because again, if it's not, we don't want to go in here. And if it is, we check if hitbox owner get is install active, because if install isn't active, we don't want to use the install modifier. We take final stun frames times equal hitbox owner get install stun modifier. And at the end, we want to return final stun frames. Now, when we take a float value and multiply it by an integer value, it is going to truncate by default. So by returning this, we're already handling the truncate. And that is how we can convert these functions from blueprints to code. And it will work exactly as our blueprint logic did, but now it will be more efficient. Now, one thing before we open up the editor, we want to go back to our hitbox actor.h, and there is something that I've added here because I made a mistake when I was saying this just earlier. I mentioned that we should include the fighter template character.h in this file, and that would be correct if we were not creating a circular dependency. So when two files include each other and rely on each other, you have a circular dependency. So this line that I told you to add, we want to take that out because we won't be able to launch the project if we have that. Instead, we want to write class a fighter template character here, which is a forward declaration, which allows us to get access to the type that we need, which is a fighter template character, without including the whole file, and thus the two files don't include each other, getting rid of that dependency. So when you're ready, go ahead and launch the editor again. Then once you're in the editor, we need to go back to Hitbox Actor Blueprint. And when we are in here, we want to make sure that we replace hitbox owner with our code variable. Now, because the blueprint variable was called hitbox owner and in the code I called it hitbox owner, it did pick up on that and it replaced it for me, which was really nice. But Unreal won't always do that, especially if you name the variable something completely different. So if it doesn't, you can look through your logic and replace every instance of hitbox owner with your code version, or you can do it the easier way, which is what I'm going to recommend, and I will go through it with you anyway. That is to right click and search for hitbox owner, or find results for hitbox owner. Go to each and every reference in here. If you named it something else, search get that variable name and just replace the blueprint one with the code one. Go through every instance and just go down the list, and I'll keep showing you. We have check collision, a couple places in here. Then we have it in our two functions that we converted from blueprint to code as well. Just go ahead and replace all these instances, and once you've replaced all of them, you can remove the hitbox owner variable in the blueprint. Again, you only have to do this if Unreal did not pick up on your variable. Once we're done with that, we want to go to the two functions we've converted and find references for them. So determine full damage is now calculate final damage. So once I find all references of determine full damage, I can go ahead and replace them. For me, it's only in one place. So I just want to make sure that I'm paying attention to everything that's hooked up here, and I am replacing them. So we have the hitbox damage coming from the hitbox data here. I don't need that anymore because we're using the hitbox damage in the code. So we can just call calculate final damage and pass the return value into take damage, just like we were doing before. The other one is determine true hit stun, and in this case we want to use our calculate final stun function, or calculate final hit stun function, whatever you called it. So we find all references, we see that this is the only reference right now, so we're going to replace it. The num hit stun frames right here can also be removed as we don't need them in there. But we will want to return the hit stun frames into take damage, so don't forget that part. We can remove this function and call calculate final stun and just replace this function here. Make sure we connect everything properly. And we can get rid of any reroute nodes or additional nodes that we no longer need on the graph. Once we've done that, everything is cleaned up and we can go ahead and test everything. Everything should work as expected. So if I go into my game, use my install, I should get more damage and more hit stun frames by the appropriate amount. Then when my install ends, I should go back to my regular value. As long as everything is working as expected, then you've completed today's episode, which is all you need to do. And there you go, guys. So now we've successfully converted a variable and 2 functions from blueprints to code in our Hitbox actor, and that concludes our Hitbox cleanup part 2 in our fighting game tutorial series. Hope you enjoyed this episode, and if you did, please subscribe. It does more for myself and the channel than anything else you can do, and it's completely free. If you want to give more support to the channel, like all these kind souls on the screen have, then feel free to check out the Patreon, YouTube membership, and Discord subscriptions. They get you extra benefits for doing so, and it supports the channel even further, so I'm incredibly grateful to all who have. If you ran into any problems while following this episode or any of my episodes, feel free to join the Discord community. I would be happy to help you out. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.